Hey guys, welcome back. This is Joel, and we will continue with our discussion on the QoS, which we had started in the previous video. Right, this is going to be a continuation of that. Just to recap on what we have done, probably have it here. Yeah, so we started discussing about QoS at the start of the session in the previous video. Then we moved towards the whole, workflow or the whole cycle of the various processes involved. Something like you have to classify, you have to polish the traffic, then you have to schedule it and then rewrite it, right? The general QoS processes, I would call this. And then what we did was we did some of the use cases concerning the policing, right? We did it per interface, we did it per traffic class. Then we also kind of looked into how we can do the same policing from a centralized data policy kind of view as well, right? We were mainly concentrating on the localized data policy in this particular video, right? But yes, you can also do this from a you can do some of these operations from a centralized data policy as well, and that's what we saw here. Then we moved towards shaping, right? We did the shaping as well. We shaped the traffic to not exceed more than 2 megabits per second, which is 250 kilo bytes per second, right? And while doing policing, we kind of put a threshold saying that our traffic should not cross 1 megabits per second, which is 125 kilobytes per second, right? Okay, that being said, now let's do the next step, right? Which is basically your scheduling. So this is where we are, and this is what we are going to do. Okay. So while doing the scheduling, what I have done is before getting to the scheduling part, I have kind of written down something here, right? This is pretty straightforward. So when you start with the scheduling, you need to now start understanding or kind of coming out or building a strategy for various of your uh, traffic classes, right? So you have different kinds of traffic in your network. This is the time where you go and kind of create those segregations or those categories. And this is what I have. So I have, for example, I have voice, video, some business application like FTP, and then I have the rest of the traffic, which is default traffic, right? And I've gone in and put in some match conditions saying that the voice is going to be matched with the DSCP value EF, video is going to be CS4, this is FTP, so I'm going to probably use like application aware routing to kind of like match with the FTP traffic, and the last one will be DSCP0. Now I'm not going to explain you what is this what is a DSCP about, right? So DSCP is something which you find in the headers, IP header fields, and giving different values for this will help you kind of like mark the traffic and then kind of define your QoS policies based on that, right? You can obviously go and check out your traditional QoS to understand what is this DSCP, what is TOS field, and all of that, right? Anyway, so now the idea here is just like any other, I would say networking device, even in your even in my VH, right, or SDWAN edge, we still have the same concept where you can now create classes and then push this traffic, a specific queue, right? So in the VH, we basically have 8 queues, right? So we have the queues going from 0 to 7, which is total 18 number. And once you match the traffic, then you can push it into any of the queue, right? Right now I have just randomly selected probably I mean, it's not random. I have kept the voice to be in q0 because q0 is something which has the highest you'll understand when we create the policies, you'll understand that the q0 basically comes with llq and all of that. So um, I put in the voice data in the q0. The video basically goes down to q1. This basically goes to the q3, and the last one is q7. Now, once we do that, we also need to define how much amount of the bandwidth should be allocated to each of the queue. That is what is done here. So you see 10%, 20, 30, 40, and then there is something called buffer, right? Even there's going to be a buffer, and you have to understand, or you have to decide how much amount of that buffer has to be allocated to each of the queues, right? You can see 40% is given a bit of it, more of bandwidth is given here because this is basically covering the rest of the traffic, right? So that's why for the rest of the traffic we're giving 40. At the same time, we are making sure that each of these traffic class gets its own share of bandwidth and buffer. And then we also have a small piece here called rewriting, which also we will try to configure. But the whole idea here is there might be a case where from the enterprise, whatever we are doing here, we are basically doing it on the VH, right? But once the traffic goes on to the service provider, maybe on the MPLS transport, the service provider might require you to mark the traffic in a different way, right? You probably internally inside your enterprise, you're using a different value, something like CS4, but when it goes out, he might ask you, hey, I want the traffic, the video traffic to be marked as 41, only then I can provide you certain SLA. So in which case you probably will have to do some kind of rewriting, right? So we will check that out as well. Okay, so now our next immediate goal is to basically go and set this up, which is basically setting up these classes and all of that, right? So let's jump into my management console here. We basically have the same setup as last video. Nothing has changed. You see the MPLS is still down. That's why you see the one over here. We have basically turned off the MPLS over here, right, on the Ethernet 0/2, so that we basically give undivided attention on BR3 only for the internet. That way there won't be any load balancing on our QS. It'll be easier for us to observe the QS related policies and so on, right? Doesn't mean that you can't use QS with two transports. You can. It's just that for our experiment, for us to look at the results in a better way, we have shut down the MPLS and all the traffic is using the internet transport right now, right? That being said, what do we do next? So like I was telling, we'll start here, right? So we will start with creating this. Let's go from left. So let's start by creating the classes first. So let's go back to my management PC. Let's go to policies. So on the policies, you will basically go to obviously the we will have to go to the localized policy, right? And we'll have to create some lists, right? So once we are here, let's go to the class map and create some lists. Like for example, we'll create something like class voice probably, right? And give this guy what the queue number 0. Class video probably next. Sorry. So we've got video and that goes to queue number 1. The next is 3, which is class Bizz, right? This is mainly for your business applications like FTP and so on, right? So there you go to queue number 3, right? I'm using different queues. I'll explain why I'm specifically using those queues probably later. But now just observe the last one from the diagram. I'm basically going to do the default, right? The default traffic, which doesn't match any of the above. I would want out of that to go to queue number 7. Let me save this. Right, so there you go. So we have this, which is cool. 0, 1, 3, and 7. What else do we want? I think we are good. We can now go down to the forwarding class or forwarding QoS class, right? So what do we do here? So this is the place where we define this the queue numbers and this buffer and bandwidth and all of that, right? So we are going to do column number 3 and 4 now. Okay, so let's do that. So let's go here and probably there is nothing. So let's add a new one. Let's give the name something like QMap to QMap. Probably say because it's towards transport. Let's say QMap to transport. You can do QoS on the service side as well. We are basically making this on the service on the transport side, right? When the traffic basically leaves the transport interface, that's where the QoS will be acted upon. And let's put the same thing here. That being said, now just observe that by default you already have a Q0, and you can see the scheduling type is LLQ. Further, the queue forwarding class is control, right? So I was actually hoping that our class voice should have come down here because we have already put that in Q0, but probably it doesn't. Anyway, shouldn't be an issue for us because we'll not be mainly using voice for testing. Let's see if it anyway comes to the running config. But anyway, so let's see here also it starts with 1. So when you're talking about 1, what we'll do is we'll start with something like we'll start with maybe for 1 we will go with 20%, right? There you go. So 20% of bandwidth and another 20% of your buffer. It's a little tricky. You need to put it right exactly. Then we can do something like random only drop. Right, these are basically the algorithms which you normally use in your normal QoS as well. And you see here, this is already populated the class video. Let's save that, and let's add more stuff. So let's go to class, sorry, the queue number 3, because that's in our list. And for queue number 3, let's go with 30%. Let's give this guy 30% bandwidth. Let's also give him 30% of the buffer. There you go. And the drops probably is going to be again random early drop, and it's going to be, let's save this. And we have one more, right? Don't we have one more? We have one more, which is my default. So that would go to my queue number 7, and I would probably give this guy 40%. Let's go and select 40 over here. Okay, that's 42. I'm having a little bit of a bad internet, so okay, just okay, that's 40, and let's get the buffer as well. 240 over here. There you go, that's done. Probably let's use a different algorithm here, maybe like a tail drop, right, for drops. And that being said, we have taken care of all the use cases which we mentioned here, didn't we? So this is pretty good. The only thing is I was expecting class voice also should appear here, because that is something we have configured it in Q0, but maybe they have changed that in this particular release, because before it used to appear that way. So let's save this anyway. Okay, maybe I did not show you this. Let me just show it again. So on the right hand side, if you see, this is pretty cool, isn't it? Earlier when we started, if you rewind back to the video, you'll see when nothing was there, all the bandwidth and buffer was allotted only to Q0. But as and when we went on putting in the values, you see how the bandwidth and the buffer started getting divided for different classes, right? So that's pretty cool. Okay, so now once we have defined this, whatever we did just now, we have defined a forwarding class. We need to go back and attach this to some policy, right? Otherwise it will not be useful. Let's go to localized policy here, and we have one policy active on our devices. We'll piggyback our policies here, right? So let's go down here and yeah. All right, so first thing is you need to enable, because it's a cloud device, VH Cloud, you need to enable these two checkboxes, because these basically will enable the QoS on the VH Clouds. This is something which I did not figure out, and I had to spend a lot of time, and then I think my good friend or colleague basically helped me to understand that, you know, we need to basically have this to enable QoS, otherwise it won't work, right? That being said, let's see what else do we do. So we are here now, we need to attach. So let's go to the forwarding class over here, and let's do an import here, because we already created the QoS map, right? So let's go and select. There you go, import, and I think that should be good. Let's save this. So once we import and once we save, we have created what you call as a QoS map, right? So while this is getting pushed, it's a localized policy, so it'll get pushed on all the 4 devices which are attached to it. So while that is happening, what we have done is we have created this, and we have attached it. I mean, we have basically created that and into a, let's say, container called as QoS map. And just having QoS map is not sufficient. We should then go and attach this QoS map to a VPN or an interface, right? Basically, the interface is where we will go and attach this. So the interface which is under the VPN, right? In our case, we obviously want this on which side? The transport side, right? If you see the diagram, we want it on the transport side over here, actually. Gigabit Ethernet 0/0. So that's where we will attach it. Okay, so let's see what has happened. This is happening still. Great. So now that that is completed, let's go and do that. So let's go to the templates. So if we go down to the templates, you'll find something called a feature template, and in that, let's go to the iNet. And once you go to the iNet, you know, this is basically the template towards our internet facing transport. Let's edit this. So once we are here, we will have to go up to the ACL and QoS part. So there you go. This is the ACL and the QoS part. Let's go down there. This is where you need to select and add the value. So I already have probably, but just to be safe, let's get the correct value. Yeah, so let's check it on the device, because we just now pushed it, right? All right, so we probably can do this using I believe it's show policy should give you, or show running also should give you this, but let's say show policy, do we have something like I think QoS maybe? QS map info. Yeah, there you go. Right. So this is the exact name which we pushed earlier. We would need to go and attach it to my bad. Sorry. We have to attach it over here. Right. Let's paste this here. Just make sure, because you're typing in, just make sure it is exactly correct. Otherwise, it would be a disconnect. Now let's update this. And let's obviously push this. There you go. Let's confirm. All right, so it's been pushed successfully. Now if we go back to the device and check the same command, I'm going to run again. You see that earlier it was just having the policy, or it was having the QS map, but now the QS map is attached to the interface, which is under VPN 0, right? That's pretty cool. Now we can also check the rest of the stuff, something like show policy, I believe QS scheduler info, right? So this will basically tell you those 4 queues and the bandwidth and the mapping which we did, right? All of that information is here. That being said, now the stuff which we need to actually monitor and use here is, let me go back to the diagram. What we are going to do is we go to the switch 2 over here, and I'm going to send in some traffic, right, from the switch 2 inside in this direction towards the VR3, so that the traffic goes through this interface and we can record some of the values, right? We can test it. So what we'll do is, let's keep this here. Let me also show you, I believe it is interface, Q, if I'm not wrong, yeah, and yeah, I think that should be good. So let's see this. Okay, see, you see here, currently, I mean, forget about the other interfaces. In fact, let me just truncate that and keep it only to the gigabit 0/0, gigabit 0/0. Yep, that's good. So this is the interface facing transport, and as of now, I just see values in. I see some values in the Q0. So this is value for Q0, right? And I also see the values even for, which is this Q2. I see some values for Q0 and Q2, right? Now the Q0 is mainly because all your control data, right? All the control information actually goes via the Q0, so that's why you see that information. Q2 is kind of like catch-all kind of a queue, right? If anything other than control as of now is going inside the Q2. Awesome. So now what we'll do is we will probably go and test it. So let's go to the switch which I was talking about. I think this is the switch. Let's go and hit enable. So what we're going to do is we have to simulate, somehow we have to simulate what? The video traffic, right? Because if you see my diagram, I have mentioned voice, video, business, and default, right? So let's voice, obviously I can't, I can still simulate, but we'll not be able to see anything visually, because everything will be going to Q0, and we already, like I said, we already have the control traffic also using the same queue, right? So we will not be able to see the difference. Whereas for video, we are pushing the traffic into the Q1, and the traffic which is marked with the DSCP CS4, right? Now let me also show you this. There's a mapping, very nice mapping on the internet, which tells you that for CS4, what is the decimal value of CS4, right? So you see here, the TOS field in decimal for CS4 traffic is 128, right? So using this, we can now simulate this particular traffic, right? So what we'll do is we'll go and do a ping to say 172.16.32.1, which is my headquarters. When I'm doing this ping, let me also put up TOS as, or I can probably, headquarters is not 40 actually, the PC, right? The headquarter PC, which we have over here, this one, the Windows PC over here. So we'll directly ping that guy. And when I'm pinging, let me put the top of TOS field value as 128, because we just now found it from that particular website, right? I mean, you can mathematically arrive that as well. I'm not gonna do that here, but you're free to try it out later. So let's send out a ping of say 1000 and repeat. Timeout, let's put 0. We don't want to wait until we get the reply, and the size is say 1300 bytes. So before I hit enter, I just want you guys to check that on VR3. See the queues, right? I don't see any other queues updating. We just have Q0 and Q2, values. Rest, you don't have anything. Great. So let's go and hit this. There you go. It is the data is being sent out, and it already got sent. And on VR3, let's go and check this again. I don't see any, any other queue getting populated, right? We can also try for the last traffic, which is my default, which is DSCP 0. So for that, I don't even have to put the TOS value because by default it is going to use that. So let's just remove the TOS 128, and by default it's going to be DSCP 0 itself, right? So let's go and do this. Same thing, and let's go back and run this. So you can see again, I don't have, I was expecting Q7 to be loaded because that is what we have defined as per our policy. We have been telling the default data should go to Q7, the video data should go to Q1. But I don't see that happening here. Q1 is empty, Q7 is empty. In fact, all the traffic is actually going to this guy, right? We sent two pings with each being 1000 packets. So and that's why you can see 2161 here, right? So it clearly shows that we are missing a very critical part. And if you observe, I actually left it intentionally so that we could have this discussion, right? So that brings to the very interesting piece of QoS, which is classification, right? We kind of missed it. So if you look at the table here, what we did is we created the classes, we mapped them to the various queues over here. We mapped, we also added the buffer and the bandwidth values, right? And all of that was part of the QoS map, which went under a VPN interface. But the thing which we missed the most is this one, right? So we kind of did not do this important piece over here, right? And that's what we are basically going to do now, right? So that is basically the classification part, right? So now when we're talking about classification, you can do it in two ways. You can either, like I said, you can do this in we can probably do this either using local control policy, or you can do it using central control policy, right? So let me do one thing. Let me show you both, right? So that's clear. So let's start with the local. So for local data, sorry, why I'm saying control, local data policy, right? Local data policy and central data policy. For doing the local way, we will have to go down to, okay, just log me out. All right, so for the local way, we basically go down to my policies again here. Remember from the previous video, we already have some kind of a access list created. We're gonna just use that. So let's use this access list. Right, when you think about classification locally, obviously the first thing which should come to your head should be the access list, right? Because you can match traffic based on access. So that's what we're going to do. So right now we don't have anything. Let's add an access list rule, right? So so here let's go and define the stuff which we want. In fact, let's do it for only one guy because like I said, I want to show you how to do it using centralized as well. So we'll just do it probably for the video, for the video traffic using the localized. So let's add a sequence rule. And what do you want to match based on? You want to match based on the DSCP value, which is for video. So again, let me show you this, right? For DSCP, you see, we want to match based on CS4. But if you see the table which I've been showing you here, this is CS4, right? But what is the decimal value of that CS4? It is 32, right? Don't confuse with the decimal value of this DSCP value and the TOS field. So these both are different. While doing ping, remember we used 128, but while writing the policy, while writing the ACL, we are basically matching on the decimal value of DSCP, which is 32 here, right? That being said, let's go back. So let's go here. Let's put in 32, which is cool. Now let's go to the actions part. Let's accept it, obviously. Let's put in a class. And this is where you can select the class, which is the video class, which you have defined already earlier, right? And is that it? Let's also go ahead and put in a counter, right? Let's call this counter again something like, okay, class video or something else, right? Cool. Let's now save this. And I believe the default is already there. Yep. Let's go and do this. Enable, activate. Since it is a local policy, it will basically go down to all the devices. Configure. There you go. Let's click OK. All right. Now that that is being done, let's go and do the redoing. Let's redo the test which we have here, right? See, currently earlier we tried sending packets tagged with the video traffic, but the queues were not getting implemented, right? Because all the traffic was going into this. The reason is, now if you look here, show run policy, what would have happened is there would have been ACL would have come in, right? See, you see an ACL here, and this ACL is basically the guy who is classifying the traffic and sending it to the right queue, right? And that's why we'll be able to see the traffic appearing, right? So let's try to now run the same thing again once. So we have it everywhere 0, but now let's go back and run the same thing, which is for the video ping, right, which we did. So this is our video ping, and let's also run the okay, so the other one would not work because we have written the ACL only for the video, right? Now let's check here. See, you can see the queues getting updated, right? Now you have the queue number 1 getting the data. Earlier it was not there because we had not enabled classification. Now that we have configured classification, right, in fact 978 packets actually were queued and 22 packets were actually dropped, right? You can see all of that, right? Which means we have just proved that by writing this policy we are now able to kind of like decide which queue the packet should go to based on certain fee, based on certain marking on the packets, right? So in this whole video I've been trying to, like I was saying, right, I'm trying to concentrate on the classification, the policing, the scheduling, and the rewriting. I'm not talking about the remarking because I'm expecting that remarking is something sorry, not remarking, I'll not be talking about marking as such, because I expect that to be done probably at a not at the V edge, right? I would expect that to be done earlier in the network, somewhere at the earlier, maybe if you have a switch which is connected to the IP phone, I would probably expect there the marking to be done, right? So anyway, so we are, what else did we do? Okay, so we are here right now. We did this one. So let me just put a check over here. So we did the local way of doing it. Now let's try the centralized data policy way of doing the same thing. When I say doing the same thing, doing this the last part which you did just now, which is creating the matches, right? Yeah, so classification basically. So for that, let's first go and remove the ACL, because otherwise you would not know, is it happening because of the ACL or because of the centralized policy. So let's go and do that. So let's go to the ACL over here, and let's go and edit this, and let's go and delete this. We anyway have default any, so that should kick in and should work. This would again go on all the devices, all the 4 devices to which it is attached. Click on next, configure. Let's put it on all the 4 devices. There you go. All right, looks like it is removed now, which means now I can go to my centralized policies and create that. So let's go to policies. Let's go to let's go here. So I'm going under the centralized policy, going to traffic policy, and under the traffic data, okay, give me a second. All right, so let me just grab this here. Yeah, so you go down to your centralized policy, right, and under the traffic data, this is where you'll find that there is already a policy which I've been using before. So I'm going to just piggyback my new stuff around this. So let's edit this, right? So you see that nothing configured yet over here. So we are basically going to add something which is going to be a QS based data policy, right? So remember, we have done application firewall before, we have done traffic engineering, now we are doing QS. So let's go and add some stuff here, which is going to be, let's start with the first one, right? The voice, probably it is not going to come into effect because I told you, because we should have probably created a separate queue for that. We should have put it in a different queue. Since we already put it in queue 0, I hardly doubt this will have impact, but anyway, let's do it while we are doing it. So since it is voice, it is going to be DSCP 46. That EF basically corresponds to DSCP 46, again from the table which I showed you earlier. And the actions basically would be to accept it. And what else? The forwarding class would be, okay, so now this is tricky, right? So here you see we don't have any drop down. Earlier we had a drop down and we did it using the localized data policy. So the trick here is probably to go down to your configuration on your any of the router, and you basically spot this, right? So the classes which you created will be of no use now, because whatever you created was on the local data policy side, right? So you'll have to use this queues which are like the default queue names, right? You'll have to use these because this is something which will help you to map here, right? So we have to use the queue values or queue names instead of using the labels which you earlier created using the localized data policy, because just to recap, we are doing this all on a centralized data policy, right? So we will go and do that. So let's copy this and let's paste it as is here. There you go. And then probably let's put in a counter as well with the same name. And let's save this. Let's add similar stuff, which is my 32. The next will be the 32, which is for video, right? And let's add the actions and the forwarding class. Now it's going to be queue number 1, and the counter is also going to be queue number 1. Let's save this. We will have to do for FTP, remember. So we, from our table, we have, where's my table? We have the third one, which is your FTP. But FTP, we are not going to match based on DSCP. Rather, we are going to use DPI, right? Deep Packet Inspection. Now, that's another advantage of using centralized data policy. In a localized data policy, you can't use DPI, right? So that is the reason. If you want to do something with DPI, then you would want to use centralized data policy for classification. So let's click on that, and here we will go and select our business applications which we have created before this list, which will have both your FTP and FTP data. Let's go to actions, and same thing, let's go to the forwarding class. Let's paste 3 over here, and the counter also probably would be the same thing. That's also 3. We are good. Let's save. Did we do everything? Okay, we also have the default class, right? So let's go to the default. So for that, we can go back to DSCP. Value is 0, and the actions are going to be your forwarding class. Q is going to be what, 7, I believe, right? We're using 7, and the counter is also going to be 7. That being said, we can save this. The order doesn't matter, so let's save. Let's see if the default action is there. Yep, it's enabled, so we have save, and let's activate. So see, it is getting pushed to the vSmart because it's a centralized data policy. Right, that being said, now that's completed, which means I can go down to my device and I can check if the policy came in. So I'll have to do something like show policy from vSmart because it's a centralized data policy. And you see here, the policy has come in beautifully, right? Whatever we created is available here, right? All the matching conditions which we put in for Q0, Q1, all of that has come in. Cool. Let's also see the counters which we created, right? Let's see the counters, which is show policy. I think it's something like data. Yeah. So there you go. These are the 4 counters which we created while creating the centralized data policy. That's visible as well. It's already getting some default packets, I believe. That's why you see some number of packets here. But let's also look into that interface counters, right? Which we have. So show interface Q, I believe gigabit 0/0, and let's tab it probably. There you go. So we have some packets here, but I want to like erase all this because when we do the test, I want to have it everything cleaned up. So let's do that. Let's clear interface. I believe it's interface statistics, and then you can put the Q number Q0, right? So let's do that for Q1, Q3 as well, and Q7. I'm just doing this so that we can clear it out, right? Now if you see the output here, see everything is 0, right? Apart from obviously this one because we have not erased it, and the 0 is because it always continuously gets the control packet, so you can never make it 0. Even if you make it 0, it will basically get the control packets into this queue. But you see the rest of them, Q3 I think still has probably 1 packet, which is fine. 1, 2, I think those are some stray packets coming in, but that's okay. So we have just to recap, we have, yeah, so that's good. We have some stuff. We have almost nullified it to 0. Now we can see there's an action. So let's go back here. Let's run the same thing which we ran earlier. We have that. So let's run it for my same thing which we did earlier, right, for video. Remember, we tested this video thing using localized data policy. Now we are testing the same thing using centralized data policy. And as the test happens, you can now refresh this and see. There you go. in your Q1, you can see the video packets, right? The packets from the video class, right, which have a DSCP value of CS4 are getting captured in this particular queue, or it is using this queue, right? So we can also do the same thing for the Q7 as well. Let's do it for Q7. So for Q7, we should have the same output here, somewhere here. Okay, so this one, let's just run this again. There you go. So this is for the Q7. We are sending in 1000 pings, right? So if you refresh this now, you should see, there you go. So we have the packets going into the Q7 as well, which is very much in line with what we wanted to do. We can also test our Q3, the FTP packets, right? I think you see some packets here because the FTP protocol, there is some kind of a keep alive, I believe. That's why you can see some FTP packets. But let's test this. I mean, when we send more amount of data, you should see a lot of huge amount of packets getting queued here. So for that, we will go to my branch 3 and hope this is still connected. Yeah, so this is good. Now let's go and try to send something here. Or let's give me a second. So let's cancel this. I want to disconnect and connect it back again. Let's do that. So let's disconnect this. Let's connect the FTP connection again. There you go. And this time we will send it here. And send with a new name. That's fine. Maybe something like data1. So you see it's starting to go in. The shaping is still in effect. That's why you'll not see. I think I've put it at, I don't know, 250 kilobytes per second, I believe. So that's why you'll not see anything going beyond 250. But anyway, so let's see if we are starting to see some packets in that. Okay, so you can see the packets have skyrocketed from 28 to 2697, right? So, and if you go on checking, you can see the huge amount of packets are getting queued and more is getting being sent out, right? So what is happening here is the application aware routing, or the DPI, the DPI, deep packet inspection, is getting kicked in, and it is able to identify that the packets coming in are FTP packets. And once it understands that, it is putting those packets inside my Q3, and that's why whenever I hit the command, you can see the number of packets increasing drastically. So that's because these packets are being sent out from here. Generally this might not immediately, you'll not be able to, you might not see this immediately, because sometimes the DPI would take some packets, initial packets, to understand what application is it. But yeah, that is the whole idea here, right? So that being said, I can stop this. I really don't want this anymore. Right, now we can also check out quickly those counters which we have on this, which I showed you earlier. Show policy, data policy filter. You can see the counters increasing. We haven't sent anything in the Q0, right, the voice traffic, so that's why you don't see anything here. But for Q1, you can see which is the video traffic. We tested the FTP, and we tested the DSCP0, which is the default traffic. So all these queues, you can see the value counters are increasing, which means our center policy is working, right? Awesome. So that finishes another interesting piece of our discussion. So where are we right now? We did this. We just zoom in, zoom out. Sorry. Okay. So we are done with the classify. We are done with the policing part, and the last part which we want to head towards is the rewrite. So rewrite, I've already mentioned here. I want to rewrite only two of the classes, which is the video and the business, right? So we want to rewrite it finally when it goes on the wire, right? So that's what we are going to do, right? So to do that, let's keep everything as is and let's continue. So what we'll do is this got logged out again. All right, so for rewrite, right, we'll basically go back to our policies, and once we're on the policies, let's go to it's going to be obviously localized, so let's go to forwarding class QoS. So you have a separate section here for policy rewrite policies. Okay, so we don't have anything yet, so we'll have to create a new one, and let's call this as rewrite. And where do we want to rewrite? We want to rewrite this probably on the WAN side. Rewrite, and let's save this. Okay, Okay, this is rewrite WAN. Now once we have named it, we'll have to add obviously a rule. So when you are adding the rule over here, remember we wait, right? So yeah, okay, so this should be good. So okay, so this is what I was trying to tell. So here the issue is that since we are again going back to using localized data policy, we don't have those centralized data policies with the classes which we used, right? We used Q0, Q1, Q2, right? Basically, if I show you on the device, I mean, ideally, I would say if you want to stick to localized data policy, basically go with that, or do the other way around. Since I'm showing you all the ways of doing it here, so that's why we are basically jumping from one to other, right? So here you see, this is the name which is kind of like present in the central data policy space, whereas this is the name which is present in the local data policy space. Since we are basically since we have everything activated with respect to the central data policy space, right? We just now went and activated the whole matching and all of that. The classification is activated with respect to this name. We can't actually go back to this now, so we have to continue using this. But the also problem is that since we are on the local data policy space, we don't really have those names, right? So let's cancel this and let's try to create those. So I think that should be a quick workaround. So what I'll do is let me cancel this. So let's go back here and let's create a list. So let's go here, list, right? Let's go to the class map. See, we have these, but in addition to that, let me now create a new class for Q1. Let's call this as Q1 because that's the name, right, in the central data policy space. And this is obviously going to go to Q1. I'm not going to do for 0 because anyway we are not anyway going to rewrite those, right? From our diagram you see we are basically going to rewrite only Q1 and Q3. So let's do it only for that. Let's go and create one more. So QUE3, sorry, should be exactly the same. UE3. Okay, so Q3, and this should also change to 3 over here, and there you go. So we have created this, and Q1, Q3. Okay, that's good. So now we should be able to go back to where my local data policy, and let's go to sorry, clicking something wrong here. Just go back to the forwarding class. Right here, let's go back to the policy rewrite, and now we should be able to create. Right, so we'll have to put the same name, which is rewrite underscore WAN. Let's use the same thing for the description. And once that is done, let's go to what? Let's add a rule. And here, let's select the class. Now it should be visible here. See, we have the Q1. And so once we are on the Q1, so when you're doing the rewrite, right, there are two things. One is obviously you can rewrite the DSCP values, which is what we want. You can also rewrite the priority, right? So there are two values. One is for low and high. So if you want to rewrite the priority, you can do that as well. Maybe while doing the policing, if you have changed the priority, you can change it back or do some changes as per the service provider's requirement. In our case, we are going to keep it as at low. And the DSCP value again for, don't get confused with the numbers. This is for what? This is for Q1, right? We want to rewrite it to, let's see. So we want to rewrite it to AF41. So immediately let me go down to my Google, the repository which I showed you. Let's go to AF41 here, and you see the DSCP decimal value for AF41 is 34. So we are going to use that. Let's go back here. So let's go and use 34 here. And the class of service, let's layer 2 class. We don't want anything to do with layer 2. So let's save this. Let's add one more, which is basically going to be for my, I think it's going to be for Q3 if I'm not wrong. Let's search the Q3 one. There you go. Priority, I'm going to keep it low. And similarly, the DSCP value here would be what do we have? We want AF21. So the AF21 would be DSCP 18. So let's use 18. There you go. I'm using 18, and the layer 2, I'm not going to touch it. Keep it as is. Okay, so that's good. So we have now created a rewrite policy. Let's save this. Now, just having the policy is of no use, right? We have talked about this before. So we need to go and attach this to some localized policy, right? So we will have to go down to the localized policy here, and obviously the one which is active on my devices is that is one of the right. So we have this one active. So let's go and edit this. Basically, we are piggybacking, right? So here, where do we do it? So this all is good. Let's go to probably the QS. See, you have a policy rewrite option here. Let's import it here, right? So once you do import, you can come here, you can import it, and we will have to obviously, do we do anything else? I believe that's good. We have to save this. So now the policy has just gone in, right? So let's save this. So this would basically configure the policy on the devices, but our job is still not done, right? If you see my diagram, what we have done is, let me just zoom in a bit. Yeah. So when you're talking about the rewrite, again, it basically follows the same steps, right? We basically have to define what you have to rewrite, right? The values which we just now defined, and so you do it under policy rewrite, right? So which we just now did. It's a localized data policy, and then you go and put this on the device, right? So this is done, but then you have to also attach this to some VPN interface, right? So once this is done, you basically take the whole thing and you attach it similar to how we did it here, right? You should go and attach this to a VPN or an interface. On VPN, it's not an or, you need to obviously attach it to an interface which is under a VPN, right? So that's the next step which we'll do. So for doing that, let's see if this has completed. Yep, that's done. So let's go to the template. And if we are on the template, we should again go back to the same interface, right? The iNet interface where we are doing everything, which is the internet facing interface. Let's go to this one. Let's edit it. So here, let's actually go down to, let's also check on the device if this has already come in. So let's say on the BR3, do we have it? Yeah, there you go. See, we have the rewrite rule has come in. We'll have to use the same name over here, I believe. So let's check that. So under the QS part, you would go down to the third option here, which is the rewrite rule. Select global, and we need to mention the exact rewrite rule, right? So let's go and pick that one, which is rewrite WAN, right? So let's take that and let's paste it down here, and let's update this. Awesome. So it's getting configured on the devices. Let's configure this. All right, so this is where it gets pretty interesting, right? So till now we kind of went and put in our so when I say interesting, what I mean is we have done this part where we kind of went ahead and rewrote as well, right? The DSCP values, but we have to now test it. So to test this, what I've done is something interesting. I have set up NetFlow on this our internet router, right? Probably I can show you the configuration as well. It's probably here. So run maybe something like flow, right? So I have this flow configuration, right? NetFlow configured on this particular interface, which is facing the internet, which is my Ethernet 0/3. So now what happens is if we start pinging from switch 2, right, with the video traffic, we'll be able to see the rewrite happening, and that will be collected over there, right? So let me just show you that. So let's go back to my switch 2 here, and let's try to ping 172.16.32, that basically headquarters, with the TOS field of 128, right? 128 is nothing but, from our diagram or from what we have here, 128 is nothing but DSCP CS4. Now when it gets collected on the net flow side, it should have AF41, right? That's what we want to verify. So let's hit this ping. The ping has gone through. Now if you go down to the our internet and if you check the flow statistics, right, it's going to tell you the value. So see here, the latest ping which has gone in, it has gone in, and this is the flow collection, right? You can see the value, the IP DOS value has changed to hexadecimal 88. Now you can verify by going to this table. If you see hexadecimal 88 over here, it is nothing but AF41, which is very much in line with what we want, right? We can also check this AF21 as well, but for that we'll probably have to send in FTP traffic, right? So if you see here FTP, let me just delete this. So let's send some, maybe let's disconnect and connect again. So I always have seen if I continue with the same connection, it doesn't work properly. So let's do this. So new name probably, and okay, so the data traffic is going in, I believe. Is it getting okay? I believe it's going in, so we can continue monitoring our flow here. Let's monitor the flow and let's see if something is coming in, right? So yeah, see, I see something coming in, which is for 0x48, right? That's the latest flow, I believe. Yeah, 0x48, right? This is the latest flow, and you'll see the TOS value is hexadecimal 48. Now let's go and check this. The hexadecimal 48 corresponds to nothing but AF21, right? And you can see from our table, that is what we wanted. So we have achieved what we wanted, right? So that's it, guys. I mean, that's what I wanted to show you. I think we have kind of covered everything in QoS which we wanted to. Just to recap, we started with explaining what is the basic understanding of QoS, the classification, the marking, policing, scheduling, and rewriting. Then we went ahead and started playing around with the SD-WAN QoS, where we did the policing to start with. We did it per interface, we did it per traffic class. Then we also tried to do the same thing using centralized data policy. Then we did a bit of shaping, right? Where we kind of shaped it to 2 Mbps. We went and then did basically the scheduling part, right? The scheduling part where we created this nice table and we said this is what we want, right? We created the classes, we configured this, we converted this into a QoS map, we applied it under the interface, and we were able to see that the corresponding class traffic was actually going to the corresponding queues. The last part is we weren't just happy with that. We wanted to kind of rewrite the DSCP values as well, and that's where we kind of rewrote it and then used NetFlow to kind of monitor the traffic and look at the flows and understand if the rewriting is actually happening, right? So that was the whole QoS stuff. Hope you guys liked it, and come back for more videos. Thanks, guys. Bye.